Good morning in grade 8. Today we will continue the lesson that we have started, or it has been started last time, parallel and perpendicular lines. This is part 2 from it. It's on page 327. And as you can see here, miss, again, I want you to remember from last time that the meaning or the new concepts that we have taken, which is the slope. Okay, the slopes of the parallel lines and perpendicular lines, and how we can find them out, and what's the relationship between them. As we have said, that if two lines are parallel, their slopes are equivalent or the same. They are equal slopes. While if two lines are perpendicular, actually if I get one of them slope, the other one will be the negative reciprocal of the first one slope. The negative, you find out the reciprocal, then you multiply it by negative sign. Okay, now, and we remember that the reciprocal is actually when you flip over or flip it over for I'm talking about the slope, you flip the slope over. Okay, while if it's a fraction, you change the position of the denominator and the numerator. And if it's, a whole number, it will be 1 over this number. And if it's 1 over number, it will become a whole number. Okay? Now, then if you remember, we try to solve a problem like equation 1. Problem 1, in which they ask us to find an equation for a parallel line to the line that has this equation, y equals negative 2x minus 9, and the new line has contains a point of 4 and negative 3. We say that since there is no y-intercept form, so I have first to find the or looking for the point slope form, which is y minus y1 equals mx minus x1, and then we substitute, and then we make it as a type or a form, and with looking like the first form, which is the y-intercept form. Y equals negative 2x plus 5. Since they are parallel, the slope must be the same, and we can notice that from the first line here, the first equation for the first line, and the second equation for the second line, it's the same slope. Okay, then we find out problem 1, another example, they ask us to find the equation of the line that contains 0, negative 2. This is 1 point in the line, and it's perpendicular. It's perpendicular to the line. They give us actually the equation of the line as the form of slope-intercept form, so it will be so easy. To find out the equation of the perpendicular line, I have first to find out the slope. The slope of a line that is perpendicular to another line is the negative reciprocal slope for the first one. So I have first to find the reciprocal. Where is the slope here? For the first line, it's this. It's 5x. Okay, y equals 5x plus 3. So first I have to find the slope for the other line, which is 1 over 5. Okay, I flip it over. Then I multiply it by negative. So it will be negative 1 over 5. Then, as you can see here, they want us to write equation, and I can, for example, write the equation, and since I have only point and slope, they give me point and they give me slope. I cannot write it in the standard form, so I write it in the point slope form. Y plus y minus y1, which is negative 2, it becomes a plus, equals the slope x minus x times, okay, x minus x1. x minus, okay, x1 is 0. So when you distribute it, again, when you distribute the slope, you will have negative 1 over 5x. Okay, now in the second part, like problem 2 in our lesson, actually, we will learn how to classify the lines to decide if my lines are parallel lines or they are perpendicular or they are neither of them. Okay, they are not parallel and not perpendicular. Now, if I have an equation, okay, and I want to find out if these lines are parallel and perpendicular, there will be no problem with me, like there's no problem actually, since I can look at the the slope itself, starting with compare if they are parallel or not by looking at the slope. If they have the same slope exactly, so they are parallel. For example, here, if you can notice, we have two equations, but they are actually written in two different forms. So to compare them, I have to write them in the same form. Okay, I cannot compare them like this. I have to convert the standard form into the point intercept form, okay, or the slope intercept form. So to convert it in this form, to convert the standard form in the slope intercept form, I have to keep y alone. So I remove first 6x by subtracted minus 6x minus 6x, so it will be minus 6x minus 24 in the other side, and here 6x will be minus 6x will be 0, so it will be gone. Now I have 8y equals minus 6x minus 24, then I will divide it by 8, divided both sides by 8. Here I will get 8 fy, and here it will be negative 6 over 8 minus 24 over 8. Now intercept, I don't care about it because they actually maybe they are the same. No, if they are the same, actually it will be the same line, so of course they will not be the same, but I will just look at the slope. Okay, now it becomes 6 over 8, as we have said. We can simplify it by divided by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 4. 8 divided by 2 is 4, and there is the sign, as you can notice here. Look, the two lines, the two slopes are actually, one of them is the reciprocal of the other one, in which you flip the denominator in the place of the numerator and vice versa, the numerator in the place of the denominator, and it's a negative sign. So actually these two lines are what? Parallel or perpendicular? They are not parallel, they are perpendicular lines. Now look at this chart here, okay, this is slide, and actually I will keep the slides. I want you to discuss with me before we go and solve a problem, got it 2 and 3. I want you to discuss with me, looking at the slides, if we have, if they are parallel for every box has two kinds of equations or two types of equations. We want to find out if these equations represent parallel lines or perpendicular lines or neither of them. Okay, yeah, let's look at the slides together and discuss what can you figure out or what you can see from the slides.